Hi, welcome to day 2 of integration by parts, example 4. Day 2 of integration by parts involved example 3, which is in a previous video, and example 4. And in example 4, actually, I'm not sure if twice is exactly the correct term. I think maybe 3 times. In any case, I'm going to use integration by parts to integrate x cubed e to the x dx. So I need to choose a u and a dv, and then use my formula. Remember, I'm assuming that this is of the form u dv, and the integral will evaluate to uv minus the integral of v du. So this is the integration by parts formula. I'm going to allow let u equal x cubed, du equals 3x squared dx. dv would be e to the x dx, and then v must have been e to the x. With this, I see that the integral of u dv would be uv minus the integral of v du, which is 3x squared e to the x dx. Okay, the problem is I don't know what the integral of 3x squared e to the x dx is. However, we might be able to find it using integration by parts. So I'm going to start all over now in order to evaluate the integral of 3x squared e to the x dx and make that a new integration by parts problem. And I'm going to now choose u and v to be factors of this 3x squared e to the x dx. And so I have different u and v values than I did for my original problem. Now I'm starting fresh, trying to evaluate 3x squared e to the x dx so I can finish this original integral. This time I'll let u equal to 3x squared, then du equals 6x dx. If I let dv equal to e to the x dx, then v must have been e to the x. If you're following along and you're concerned that this is just one possible choice of u and dv, and when you're confronted with this integral you may not know which choice to make, don't worry, it will become clearer as you get more practice. This problem will show a little bit of insight. So I'll talk about that when I get this problem done again. Okay, so anyway, integrating this with this choice of u and dv, I find that it is equal to uv minus the integral of v du. Again, the integral I'm left with I can't do by inspection, but I believe that I can do it with integration by parts. And so I'm now going to do a third integration by parts simply to evaluate 6x e to the x dx, or the integral of 6x e to the x dx. Okay, fine. Now I need to make new choices for u and dv for this new problem. And I'll let u equal to 6x. That would make du equal to 6x dx. dv was e to the x dx, and v must have just been e to the x. So I'll rewrite this integral, which is a product of 6x and e to the x dx, which I called u and dv, has uv minus the integral of v du. Okay, notice the derivative of 6x was just 6 dx. And so now I'm left integrating 6x, or 6e to the x, which I can do And so finally I am able to complete this integral, which I needed in order to complete this one. All of which I was required to complete my original integration problem. So I'm going to rewrite my first integration, or my first set of uv minus integral of v du, with the actual value substituted in for integral of 3x squared e to the x dx. I'm going to do that down here, and I'm going to sum up saying integral of x cubed e to the x dx equals x cubed e to the x minus this thing which was so hard to find, in this case, and I've taken a second to check all that. Okay, and we could find the derivative of this and verify that we got x cubed e to the x dx. That is in fact the antiderivative of what we were trying to find the antiderivative of. Notice that my choice of u and dv left me with an integral that I couldn't really do without integration by parts. However, this integral was easier in that it was the degree of the polynomial was less. It seemed to be closer to something I could integrate. And after I applied integration by parts again, I was integrating 6x e to the x dx even better. And whenever I finally made another uv substitution in order to evaluate this integral, I found that u dv was something I could actually integrate. So I was able to evaluate this, plug it back in to get this integral, which was required to finish my original integral of u dv with the substitutions, or v du with the substitutions I made in the very first problem. So integration by parts to get this, which was needed to do integration by parts to get this, which was part of an integration by parts application to find that. So 3 integration by parts. My choice of u and v was somewhat guided by the fact that the integral that I was left with each time, although it wasn't maybe doable by inspection, it was closer to something doable by inspection. And what that means I haven't really formally defined, but I'm seeing that with each successive application, I'm left integrating something that's easier than the previous, and so I'm getting somewhere, and I'm finally able to evaluate u dv this time, which allowed me to evaluate u dv from the previous, which was u dv in a previous. Okay, that's example 4, and that ends day 2 of integration by parts. Notes.